Dear student, today we consider one interesting problem about analytic function of complex variable of higher engineering mathematics. Now here given the problem, test the analyticity of the function w equal to sin z and hence derive that d dz of sin z equal to cos z. So we have to prove this. We have to find analyticity, whether it is analytic or not. W equal to sin z is analytic or not. And also we have to prove d dz of sin z, we know cos z. We have to prove this. Now, analyticity means we know, suppose w equal to u plus iv. So if we have du, del u, del x equal to del v, del y, del u, del y equal to minus del v, del x. If we have this equation, del u del x equal to del v del y, del u del y equal to minus del v del x, then it is called, then w equal to u plus iv is called analytic. This is called Cauchy-Riemann equation. Now we want to prove this. Del u del x equal to del v del y, del u del y equal to minus del v del x. So solution is start. This is very easy problem. W equal to given sin z. Sin z given. W means u plus iv and sin z, z means x plus iy. Z equal to x plus iy. We know z equal to x plus iy. So this is our sin a plus b formula. Sin a plus b means sin a cos b plus cos a sin b. We get this one. Sin a plus b means sin a cos b plus cos a sin b. So we know this formula. Now we know from complex trigonometry, we know this sin cos, first cos we consider, cos ix equal to cos hyperbolic x and sin ix equal to I sin hyperbolic x. We know this formula. Cos ix equal to cos hyperbolic x, sin ix equal to sin hyperbolic I sin hyperbolic x. Now using this formula, we get sin x cos iy, we can write cos hyperbolic y, and cos x sin iy, this is I sin hyperbolic y. We get this one. So this implies u plus iv equal to sin x cos hyperbolic y, I cos x sin hyperbolic y. So we get this cos x cos hyperbolic, sin x cos hyperbolic y, cos x I cos x sin hyperbolic y. This is our calculation. After calculation we get this. So if we equating real and imaginary parts, u is real, here this one real, iv this is imaginary, this is imaginary. So equating real and imaginary parts, we get u equal to sin x cos hyperbolic y and v equal to, this is v equal to cos x sin hyperbolic y. So we get u is sin x cos hyperbolic y, v equal to cos x sin hyperbolic y. Now I want to write this result here. U equal to, we get sin x, I rewriting this line, sin x cos hyperbolic y and v equal to, this is cos x sin hyperbolic y. So we get this one. Now we want to find del u del x, del u del y, del v del x, del u del y. Now del u del x, del u del x, when we differentiate partially with respect to x, then cos hyperbolic y, this is constant, this will be outside, we get del x sin x, this one, and this is del x of sin x is cos x, so we get cos x cos hyperbolic y. This is number 1 we consider. Again we differentiate this partially with respect to y. If we differentiating partially with respect to y, then del y sin x cos hyperbolic y, then this sin x constant because we differentiate partially with respect to y, and ddx of del y cos means this is sin hyperbolic y. Now we have to remember when we general differentiation, cos means we write minus sign, but in hyperbolic cos also cos also positive, sin also positive. So we get this one. Now u is finished. Next we consider v. Del v, this is number 2 we consider. Del v del x v. V means cos x sin hyperbolic y. We differentiate partially with respect to x, then cos is ddx of cos means minus sin x, and this is sin hyperbolic y remains same. This is number 3 we get. And del v del y we consider. Again we differentiate this one partially with respect to y. Del y v means cos x sin hyperbolic y. So this will be cos x, ddx of sin means cos hyperbolic y. This is number 4. We get this is number 4. Now what we get? From 1 and 4. 1, 4 del u del x cos hyperbolic y, and del v del y cos x cos hyperbolic y. So right hand side are equal, so left hand side also equal. From 1 and 4 we have what we have? Del u del x equal to del v del y. So we get this condition. Next, so we get from 1 and 4 we get del u del x equal to del v del y. Again from 2 and 3 both the results are same. Sin x sin hyperbolic y, sin x sin hyperbolic, but one is positive, one is negative. So del u del y equal to from 2 and 3 we have what we have? Del u del y equal to minus del v del x. So what we get? We get del u del x equal to del v del y, and here we get del u del y equal to minus del v del x. We get this. So this is nothing but our CR equation. So Cauchy-Riemann equation. So Cauchy-Riemann equations are satisfied and partial derivatives are continuous. So Cauchy-Riemann equations are satisfied. This is Cauchy-Riemann equation, del u del x equal to del v del y, and del u del y equal to minus del v del x. These two are called Cauchy-Riemann equation. So Cauchy-Riemann equations are satisfied and partial derivatives are continuous. Hence sin z is analytic. Sin z is analytic. So this is our analyticity, test the analyticity of the function this. So what we get after calculation, we get sin z is analytic because it satisfies Cauchy-Riemann equation. Next, second part we have to show sin z equal to dz of sin z is cos z. Now we have to prove second part. Next, second part we have to find. In second part, since w equal to, we know, u plus iv, so dw dz equal to del u del x plus I del v del x. By definition of partial derivative, we know this dz of w equal to del u del x I del v del x. Now dz of w means sin z, w equal to sin z. So this one we know, w equal to sin z, and del u del x we know del u del x cos x plus cos hyperbolic y. So this will be cos x cos hyperbolic y, and del v del x we get minus sin x sin hyperbolic y. So this is minus sin x sin hyperbolic y. We get this one. So this will be cos x, and this cos hyperbolic x y, and this is minus sin x. So this I we write down here, I sin hyperbolic y. We write in this way. Now we know this formula, cos ix equal to cos hyperbolic x, sin ix equal to sin ix equal to I sin hyperbolic x. We know this formula. Cos ix equal to, in complex trigonometry, cos ix equal to cos hyperbolic x, sin ix equal to I sin hyperbolic x. Now cos hyperbolic x we can get cos ix. So this will be cos hyperbolic y, means we can write cos iy, this one, and sin x remains same, I sin hyperbolic y, I sin hyperbolic x means sin ix. So this will be sin iy. So we get this. Now this is nothing but our cos a cos b minus sin a sin b. So cos a cos b minus sin a sin b, we know this formula from lower class, cos a cos b minus sin a sin b, this equal to cos a plus b. We know this formula, cos a cos b minus sin a sin b, cos a plus b. So cos a cos b minus sin a sin b, then this will be cos a plus b. So we get this one, cos a plus b, x plus iy, and x plus iy means z. So what we get, d dz of sin z, d dz of sin z, this is cos z, and this is our proof. Hence write that d dz of cos z equal to d dz of sin z equal to cos z. So d dz of sin z equal to cos z. So this is the proof. Hence proof. So dear students, I think this solution is clear. This solution is very easy. No one can say this solution is difficult. Just you have to know the formula of differentiation. Just simple differentiation formula easy. Then ultimately we can easily solve this problem. If this solution is easy, then please subscribe my channel and like this video. If it is difficult, then write in comment box. Thanks.